Underwater welding. Many of us must have heard this word, but very few of us understand what it is actually. This welding process comes as a surprise to many, as how could anything involving exposed electricity safely take place underwater? Underwater welding was invented in the early 1930s and is still used for maintaining and repairing fully or partially submerged marine structures. Inland hyperbaric welders can work on small seacraft, dams and bridges. On the other hand, offshore welders have to work on ships, oil rigs, pipelines, and underwater habitats. They may even have to perform welding work on nuclear power facilities. Underwater welding process is quite similar to welding on land. Both types of welding employ the same basic equipment and techniques. Hence, there is no doubt that underwater welding is a dangerous occupation. Underwater welding work is needed when there are any structures or ships that require salvage. The depth in underwater welding work can go as low as from 30 to 400 feet of salinity water. Basically, there are two types of underwater welding, wet and dry. Dry welding or hyperbaric means the welding works are carried out in atmospheric pressure, in a chamber from which water has been displaced. The welder may completely or partially be in the chamber, depending on the size and configuration of the chamber. Wet welding or underwater welding, on the other hand, is performed totally immersed underwater. Wet welding exposes welders to much more electrical hazard. Lethal electrical current, if engaged at a closer than safety distance, shall involve severe electrocution injury, such as cardiac arrest or even death. Shielded metal arc welding, which is also known as stick welding, is a popular choice for wet welding. Before carrying out this weld, the underwater welders check the surroundings for any obstructions or safety hazards. It is also crucial that they keep electrodes clean. Using this method, welders create an electric arc using a consumable electrode that is energized by power supply. The arc is created between the electrode and structure being welded so that the filler material is melted and deposited at the joint. When everything is ready, the diver welder signals the team to switch the power on. The power source can generate 300 to 400 amperes of direct current to charge the electrode. However, initiating the electric arc requires a fair amount of skill. The thing to think about here is that when the current is generated on such a large scale, why is the diver not electrocuted? The answer is because of the layers of gaseous bubbles. These gaseous bubbles are produced when the arc melts the flow. This layer acts as a shield to the weld and prevents electricity from conducting beyond itself. This bubble is most often composed of 70% hydrogen, 25% carbon dioxide, 5% carbon monoxide. While these bubbles form an insulating layer to protect the diver from the current, on the other hand, they also cause many problems. These bubbles obscure the welding area. That is, they reduce the visibility of the welder. These bubbles can also disturb the welding pool if the diver is not careful. Underwater welders face much greater dangers compared to land-based welders, since there are various elements to contend with, such as atmospheric gas, water and gas pressures, specialized diving and welding equipment, limited space in water, and electric current supply. Underwater welders work in remote and dangerous locations, such as offshore oil rigs and pipelines. The dangers of underwater welding include drowning, explosions, electric shocks, decompression sickness, hypothermia. As there is an element of danger involved in this job, necessary safety precautions must be taken to reduce the risk, but the risk is still there. So, this is everything about underwater welding. Hopefully, now you know how underwater welding is done. If you think this video is informative, do like this video and subscribe to our channel.